Hello guys, this is Tafadzwa from StackDev and welcome to my YouTube course. In this tutorial, we are going to look at Spring Webflux. So Spring Webflux is simply a para version of Spring MVC, but that fully supports or implements the non-blocking architecture that uses reactive streams. So what this means is Spring Webflux was actually implemented from the project Reactor, which is a Java project that mainly focuses on synchronous programming and reactive streams. So unlike Spring MVC, which is blocking, Spring Webflux is actually non-blocking and it supports back pressure. So what this means is, so for example, you can take an example where for you are in a restaurant and you want to order food from that specific restaurant. So the usual thing that usually happens is when you order food, a waiter comes to you, they will provide you with a menu, and once you have made a decision, the waiter will come back to you, and then they will take your order to the chef. So instead of the waiter having to wait for your order to be processed by the chef, the waiter can actually go ahead and serve other clients. So what this means is there is no that waiting period, or it is not the process is not blocking, which means the waiter doesn't necessarily have to wait for your order to be processed before they can actually go ahead and serve other clients. So just like with Spring MVC or with the project Reactor, it uses the same concept, but in this case it uses events something called events loops. So I think events loops, it was actually implemented way back, for example, with Node.js. So instead of using threads like what like old Java applications used to do, like for example, for you to achieve asynchronicity in an application, you do have to assign as many threads as possible, and then you can actually go ahead and use those threads to sort of like perform a non-blocking architecture, or perform an asynchronous kind of architecture. But with Spring API or from the project Reactor, it actually uses a concept of event loops that is actually being used, for example, with Node.js. So with these events loops, it gives the flexibility in terms of that the reactive streams or the application won't be blocking, and it actually means that you can actually with event loops, you can actually use a less number of threads, or somewhat actually fixed number of threads. And if you have less number of threads, it actually means that you have less memory. So in terms of performance with Spring Webflux, you can actually see that your application can actually go ahead and perform a little bit better, but this doesn't necessarily mean that you'd have to actually go ahead and place all your Spring MVC with Spring Webflux. I think we'll actually look at performance, I think, in the last section of this, in the last video of this series. So also with Spring Webflux, it also supports, for example, high availability as your application scales, because with Spring Webflux, it uses the net server, which supports non-blocking operations. So which means everything from top to bottom in the Spring Webflux, it will be non-blocking, right? So it means it starts from the server, for example, to the database. We're going to talk about the database shortly once we get started coding. Spring Webflux also supports the non-blocking I/O for WebSockets, TCP, UDP. So all these kind of transport protocols, they will be done in a non-blocking way. So that's it for the introduction. So let's quickly go ahead into the video sections itself. So for this tutorial, we're going to create a simple RESTful API using Webflux. So this will be the first part, or the first segment of the video, and then in the next segment of the video, we are going to create a Spring web client. So with the Spring web client, we are simply going to actually go ahead and fetch data from our Spring RESTful API. So we're going to use Spring web client. So Spring web client is just an extension of the Spring Webflux. So unlike in Spring MVC, where you use, for example, if you want to get data from another service or from another server, you can use the REST template. but the REST template is blocking. So like I said before, everything has to be non-blocking. It has to be somewhat perform asynchronicity through from top to bottom. So in this case, Spring Webflux, it has something called Spring WebClient, which actually go ahead and supports asynchronous calls to a server. So we'll look at Spring WebClient, which way we are going to create, I think, a separate service that will be able to get data from our RESTful API. And then in the last video, or in the last section of this segment, we're going to compare Spring Webflux versus Spring Web MVC. So most of the things that we're going to compare has to do with performance. So for example, we're going to compare whether truly Spring Webflux assigns a fixed number of threads when you run the application, or when you have, for example, concurrent requests, unlike Spring MVC, which assigns multiple threads for multiple requests, right? So we'll also do some load testing as well in this case, which means we're going to pay, for example, if we have a concurrent request that we are going to push to a server, we want to see if Spring Webflux truly does the back pressure, which is a programming paradigm where you can actually go ahead and handle multiple requests from a server without necessarily overwhelming the server. So with this purpose, so with the architecture of event loops, our Spring Webflux should be able to take concurrent requests at a time. So the tool that we're going to use for this is we're going to use the Apache JMeter. So with this said, I hope we are now ready for the coding, so stay tuned. All right, so first of all, just quickly go ahead and jump to Spring Initializer. So here we just want to initialize our project. So for the metadata for the group, I'm just going to put the name of the channel, StackDev, and then for the name of the project, I'm simply going to say Spring Webflux. And then for my dependencies, the first dependency that I want to use, this Spring Reactive Web, right? So this is the one that gives us the entry point to the Spring Webflux world. So this comes with Spring Webflux and Neri. And then for my database connection, I'm going to use Spring R2DBC, right? So I think we're going to go down in detail for the Spring R2DBC. So the R2DBC allows us to actually persist data to a Postgres database, but it supports persisting of data in a non-blocking way, unlike the normal RDBC, which is blocking. So in this case, we have to use R2DBC. I think we'll get more into detail with that. Then the next dependency that I need, I can use Lombok. Then the next one, I need our database connector. So we're going to use Postgres. So I'm just going to use this Postgres driver. So once you have your dependency set up, just quickly go ahead and click generate, right? Once you generate the project, you should be able to actually go ahead and start off. All right, so once you have generated your project, so if you open the project, you should see a folder structure similar to this one. So inside our folder, if you go to the pom.xml, right? So since we're using Maven, it will come in this XML format. So in this pom.xml file, we can actually see the dependencies that we installed, right? So the first thing that you can see is we use Spring Data, the R2DBC, right? So since we want to create an application that is non-blocking from start to bottom, it is highly recommended that you use the R2DBC connector, right? Because it will make sense for you, for example, if you use the normal RDBC connector, which is blocking the application, the whole application stream has to be non-blocking. That's how you get the full power of using Spring Webflux. Then for our connector, since we're going to use Postgres as our database, we're going to use the R2DBC Postgres connector, right? Then for this connector, this Postgres connector, you can just quickly go ahead and remove it because you want to use the reactive one, which is the R2DBC Postgres connector. So once you remove that one, you can actually go ahead and refresh your your POM so that it will reload the dependencies, right? So Lombok, we're going to use it for our annotations so that we won't have to write much code, right? So it will be used for code that has less boilerplate, right? Then once you are done with this, I think for the most part we are done with our pom.xml, right? So once you've got this set up, now let's quickly go ahead and start coding, right? So for RESTful API, I'm simply going to create different packages for different things, right? So the first package that I'm going to create is going to be called controllers, right? Then I can create another one called models. I like to package different things into different packages so that it'd be easier to maintain the projects, right? Then for services, we can create something called services, right? So here I'm just creating the packages, right? Then what else? So we'd need repositories. So for our RESTful API, we're simply going to create a simple CRUD API, right? Where we're going to create, read, delete, update data from our database, right? So it will be a sort of like a user registration, something like that. So let's quickly go ahead and go to models and create our models, right? So for our model, I'm simply going to create a Java class, right? And then I'm going to call it users, right? So once we have this class, right, ready, the first thing that we need to annotate it, we just need to tell Spring that this is going to be a data class, right? And it's going to represent a table, right? So once we have these two, the next thing that we need to put perhaps is you need your setter and your getter methods for a class, right? So remember we use Lombok. This is where it comes in handy. So we're going to create our no args constructor, which is going to be our default constructor. Then we're going to have our all args constructor, which is going to be our non-default constructor. So once we have that set up, we need to actually go ahead and create our fields, right? So for our fields, I'm simply going to start with an ID. So this is going to be a simple ID. So I'm simply going to say it's a long. Then the other field that I need is, for example, I need the name. And then I need the surname. I also need the email. So let me just copy these. That won't have to rewrite code, email, and maybe password, right? So this will just, like represent our user registration, our users table, right? So once you have this, you'll be good to go, right? So surname. So here I can just say maybe usernames, something, right? So once we have this, right, the next thing that you need to do is you need to make configurations to your database, right? So one trade-off that Spring Webflux has is in terms of managing your schemas and managing your data. So the R2DBC, unlike the normal RDDBC, which supports schema managers, for example, like the Spring Data JPA, which comes with, for example, Hibernate, which supports things like automatic creation of entities. Once you create or your model like this in Spring MVC, we know that this table will be automatically created. But with R2DBC, we can't use some ORM frameworks like Hibernate because most of the things actually violates the nanny blocking architecture that we want to accomplish. So there's a little bit of trade-off. So for our database schemas, you'd have to manually manage your database schemas, which means you'd have to manually create your database. So once we have a mapper, an object mapper like this as our data, it will be just more or less like a blueprint to our database. So you find out that you need to manually create these, right? So you can actually go ahead. So for database schemas, again, you can actually go ahead and use something like, for example, Liquibase to manage your database schemas, right? But in this tutorial, we are simply going to create the database on our own, right? The tables, I mean, the schemas on our own, right? So just quickly go ahead to resources, right? So inside resources, we just want to create a file called schema.sql, right? So inside this schema.sql, right, this is where I want to create my table, right? So I'm simply going to write my native query. So I'm simply going to say drop table, right? So because we're going to be restarting this application, so if the table exists for the purpose of the demo, right, I'm going to drop a table called users, right? So for the table, I'm simply going to create table users, right? Then ID, it's going to be a serial, then it's going to be a primary key, right? So if you use things like Liquibase, you won't have to manually create write the queries like this. You will be automatically creating your schemas, right? So this, I'm going to create a name with a varchar of, let's say, 255, right? So the other things, I think they're just strings. So let me just copy this, right? So name, surname, email, username, password. Yeah. So surname, email, and this is username, this is password, right? So once you have your schema like this, right, this schema won't be automatically created. You need to actually be able to run the schema. So for the most part, so before I do anything else, let's just go ahead and create our database configuration file, right? So I'm simply going to create a Java class, right? So this class, I'm just going to call it dbconfig, right, like so. So inside this db config, what the first thing that I'm going to do is I'm just going to annotate it just like what we do in Spring MVC. I'm just going to annotate it as a configuration, right? So that will tell Spring that, okay, you need to run this file because it's a configuration file. So every time we start our application, this class, this class will be automatically run. So the first thing that I'm going to do is I'm going to extend the R2DBC connection so that we'll be able to actually the R2DBC configuration, so that we'll be able to actually go ahead and configure our Postgres database, right? So in this case, I'm simply going to implement the connection factory method. Simply going to override this, right? So for our connection factory, what I'm simply going to return here is I'm simply going to return connection, this connection factories for R2DBC, then .get, right? So in terms of then here inside it, you put the URL of your database, right? So the database, I'm going to use the R2DBC connector, and then I'm going to use, so it's going to be a PostgreSQL. Then my database is going to be, I'm just going to put my local database. So in this case, it's 54. I'm going to run it at 5433, right? And then the database name is going to be called testdb, right? Like so. So once you have configured the connection factory, we need to be able to actually create our table, right? So what we want to do is whenever we start our application, we want it to be able to actually go ahead and recreate our table, right? So we can use, we can create a bin called initializer, right? That will be able to do that, right? So what I'm going to do is I'm simply going to create a bin, right? So this bin is a function and it's of type connection factory initializer. connection factory initializer like this. Then I'm simply going to call it initializer. Then for this connection factory, in terms of the arguments, it takes a connection factory like so, right? So this will be a new instance. It's different from this one. It will be a new instance. So we're simply passing the new new instance of our initializer. So I'm just going to create a variable called initializer, which is going to create a new connection factory initializer like so. Then I'm going to semicolon. Then after this, I'm going to initialize it. So I'm simply going to say initialize dot set connection factory. So for connection factory, we're simply going to pass the one that we've passed in our method. So after you've done this, the next thing that you need to do is we now want to create something called a database populator, right? So I'm simply going to say database populator is equals to new composite database populator like this, right? So we have created, we have initialized our object, right? So we are simply going to say database populator dot add populators, right? So for our populators, we are going to add from our resources, right? So in this case, initially we have something called schema.sql, right? So we're going to say resource populator. Then inside this resource populator, we then want to pass our class resource. So in this case, for our resource, it's going to be called schema.sql, right? Like so. So if you have many resources that are going to be in your project, so for example, you have schema, you have data for populating, let's say some default fields or something like that, you can quickly go ahead and use this data populator to actually go ahead and populate that, right? To populate your data in your database, right? So this is one of the trade-offs that Webflux has, that R2DBC has, right? Because you can use, like some advanced ORMs like Hibernate because they are blocking, right? So maybe just go ahead and quickly, if you want to contribute to that, if you have a solution that can solve this, you can actually go ahead and look up the R2DBC repo. Maybe you might have a brilliant solution that will be able to do this for us, right? So we can actually go ahead and look at it. So in terms of so once you have populated your data, then you need to set the database, right? The database populator. So for the database populator, we are simply going to initialize with the database populator that we've added stuff to, right? So once you've done this, then you simply return the initializer, right? Like so. So after you have finished initializing your database like this, the last thing that you probably need to do in terms of database connection is you probably need to quickly go ahead and go to the applications.properties. So inside application.properties, I'm simply going to now manually sort of like inject R2DBC to the, so it's R2. So you can either use so inside this application.properties, what we want to do is we want to be able to connect to our database, right? So remember, the database would have the username, the password, so we want to be able to connect to it. So to connect to our database, you simply go to this file, the applications.properties, so r2dbc.url. so in this case, you need to pass your connector. So in this case, we're going to use r2dbc like so, right? So like just like what we did inside that configuration. So SQL, so we want to pull out our connector. So in this case, it's going to be on localhost. So mine is going to be run on 5433. I know that the default is 5432, but I'm just running it on my local cluster on 5433, right, as a service. So once you have this, the next thing that you need is the R2DBC username, right? So let me just copy this, right? So we need the username, the password, yeah, and maybe maybe the connection pool name, right? So R2DBC. So in this case, I'm going to say username, right? So the username for my posts from my database is going to be Postgres. Then the password, I'm simply going to put C3. Okay, I'll put this one later. So need to copy it from somewhere. So password. So this is password. Then so we have the username, the password. Then the last one we can say let's say pool, so that we will be able to do a little bit of connection pooling. So enable. This one is not necessary, but might as well put it, but it's not necessary, right? So then the other one, for my logging, I'm not going to have any logging, so it's fine. So here you just put your own password, right? So I'm simply going to say password, right? So once we have this set up in your applications.properties, you're good to go, right? It means we can now connect to our database, right? So once this is ready, the next thing that we probably need to do is to actually go ahead and create some more things, right? So the second thing that we want to create is we want to create our repositories, right? So for our repositories, so for us to be able to actually go ahead and persist data to our database through the R2DBC connector, we need to create our repository, right? So the repository that I'm going to create is going to be an interface, right? So I'm simply going to call it user, for example, user repository. So right, so for this interface, it's going to extend the reactive CRUD repository, right? So here we are not using JPA, right? So you need to extend from the reactive CRUD repository. So just like the JPA for Spring MVC, it takes the model and then the primary key for your table, right? So we need to annotate this repository with @ repository, right? So there's no difference, just the same thing. I would do it in Spring MVC. So after creating the Spring repository, the next thing that we probably need to create is our service, right? So for all our business logic, we're going to put it in a service class, right? I'm going to create a service called user service. So inside this service, I'm going to annotate it with service, right? Then the next thing that I probably need to do is to bring up my repository, right? So I'm going to inject my repository with AutoWired, right? And I'm simply going to say user repository. Then I'm simply going to say user repository, like so, right? So once we have our repository set, the next thing that we probably need to do is to start getting data from our database, right? So with Spring Webflux, right, it has two reactive streams that it uses, right? So it uses something called, I'm just going to put in the comment, mono, right? So if you want to return a single object, right? So for example, you want to return a stream of a single object, you wrap your return type, your response with something called mono. So mono returns from 0 to 1, right? So this is just a single instance, or a single stream, right? Then if you want to return multiple streams, for example, like a list, let's say a list of users or something like that, you use something called Flux, right? So Flux is used to return Flux is used to return multiple items, right? A reactive sequence of multiple items. So this is a reactive sequence of items, right? So then the other one, it just returns a single. This is a single, right? This is a single value, right? Or empty from 0 to 1, right? So once we have these two set aside, let's first create our get users service, right? So the first method that I'm going to create is going to be called get user, right? So I want to return, right? I want to return a single object of type user, right? So let's say you want to create something like maybe get user by ID, right? So get user by ID, something like this as a service. So we probably need to pass the ID. Then inside the return, we're simply going to say return user repository dot find by ID, right? Like so. Then we pass the ID, right? So once you've done this, one thing that you probably notice is, right, is you cannot this class the provider for this repository, it returns a mono, right? So instead of you having to return a user like this, you need to repeat inside the mono like so. So this is called users, right? So our model, we put our model class, then we just import this like so, right? So what this means is we want to get a single instance of an object, right? So for a single instance, we're using Webflux, we repeat inside the mono, right? So like what you defined here. So to return a single instance, it's mono. Then to return multiple instances or multiple sequence of items, reactive multiple sequence of items, we use Flux, right? So this is the get user by ID. So let's just create another one. Let's say get users, right? So public get users, right? So in this case, we said if you want to return a multiple stream, we use Flux, right? So we say users. So let's just quickly go ahead and import Flux, right? So import the class Flux. Then this one, I'm simply going to call it get users, right? So this service will get all the users, right? So in this case, I'm simply going to say return user repository dot find all, right? So the normal, just like the JPA, right? The normal methods that you would find in a JPA, you can also find it in your reactive CRUD repository, right? So you have to find by user, find by ID, or those predefined accessor methods for our database queries, right? So in this case here, we're getting a reactive stream of data, which is find all, right? Then the next thing that we probably need to create for a service, let's just create maybe add user, right? Add user. So let's say we want to post the data, want to post user, so want to pass so I'm not going to create a DTO, I'm just going to use our class as our DTO, right? So in this case, so to add user, right? So to add user, this is going to be a void, right? So to add user, I'm not going to create anything, right? So I'm just going to simply return a response to say, let's say user created. So remember, this is at a service level, right? So the client is not directly interacting with this service, right? So this is just a business logic, right? So for our client, we're going to create a controller that is going to do that. So this is at a service level, is just a service that's going to interact with the database. So the controller and the service are going to communicate with the database. So for the add user, I'm simply going to say user repository dot save, right? Just like what you do. Okay, so you save. Then since we're going to save the data to our repository, the next thing that you need to do is you need to terminate the stream, right? So to terminate the stream, you can just call subscribe, right? So we're going to subscribe. So if you say subscribe, what happens is it returns a disposable that helps in canceling the subscription, right? So it means we are subscribing to the data that we're going to return on save. So once you save, you need to put subscribe, so that it will sort of like return a disposable that will sort of like terminate sort of like the transaction after it has finished saving, right? So this is the add user. So from this, you can actually see that it's just the normal way you do it in Spring MVC, but the only difference is you need to make sure that you wrap your classes or your return types with either mono or flux. That's the only difference. Then the other thing is it also uses it also supports functional programming, which means if you have some other things that you want to write, for example, after subscribing to the data, you want to perform some sort of functionality within it, you can actually be able to use the functional programming concepts that were introduced in Java 8. So let's just demonstrate, right? So I'm going to create another one called, let's say, update user, right? So in this case, if I update user, I want to be able to return that user to the user that we have updated to the client. So this one I'm going to call it update user, like so, right? So again, this one is going to, I'm not going to create a DTO, it's going to take the user object from our models, right? So what I'm simply going to do here is I'm going to say return, then user repository. So the first thing that I want to do, right? So if you want to update, a specific user, right? We have to find the user first, right? So I'm going to say find by ID. So what I'm going to do here is I'm going to say for the user that we have passed, obviously we have the ID, we want to get the ID of the user, right? So once we find the object that we want to update, right? So we can say if the user is not found, so we need to get the exception, right? So we just return a mono with an error here, right? So we can say mono.error. So this is functional programming in Java, right? So here we can just throw an exception to say, for example, let's say user not found or something, right? So this is just an exception that we are returning, right? So here we used switch if empty, right? So for example, if you try to find this user and then this user does not exist, we just throw this exception. So one thing we need to note here is for this exception, right? Since we're throwing this exception, we're going to return it as a mono again, right? So that it will be it's a reactive response that we are returning, right? So this is very important because, for example, if you write anything that is blocking, so for example within our service, so if you write anything that is blocking, it means it defeats the whole purpose of trying to write asynchronous code or trying to have an asynchronous service, right? So you have to make sure that everything that you're going to do, it won't be blocking. So even though it supports some blocking, so you can block some streams if you want, but in this case we're just demonstrating the whole asynchronous way from top to bottom. So once so for example, let's say you find the user, right? What do you want to do with the user, right? So let's say if you find the user that it exists, right, you want to map through the data of this user. So you say old user. So this is the user that we find, right? So if the user exists, what do you want to do with it, right? So we want to say if, right? So if user, right? So if the user that we are passing dot get, let's say surname, right? Let's say we want to update the surname. So if it is not equal to now, then we're going to update the old user that we just fetched from the database. So we're going to say set surname, like so, right? Then you say user, the one that we're passing, dot get surname, like so, right? So what we are simply doing here is we are saying, so if we get the user from this, right, we're going to map it as an old user, right? So once we get this old user, what we want to do to this old user, we want to update the details of this old user with the new details that would have passed from our object here, from the top here. So once you do that, you can actually go ahead and replicate the same functionality to the rest of the entities, right? So we can say this is get username, get surname, let's say get username. So this is get username. So set username, like so, then get username, right? So we are simply updating, right? Get name, then we set the name of the old user, then we were setting it with the one that we're getting from the client. So what else? Get email, Then we set the email, then we're updating it with the email that we're getting from the client, right? So once you've done this, then we just simply return the new updated user, right? So we have updated the old user, so it means we return it, right? So once you return it, right, what's the next thing, right? So once you return it, then we can flat map, right? So that we have sort of like a single instance object that is updated, right? So we can flat map the map that we just updated the user. So once you flat map it, you'll be able now to save this, right, to our database. So user repository dot save, then you save it with so I'm just going to create the shortcut of saving here, right? So once you flat map this whole object, right, you then save it to the database like so, right? So this update user service was just to demonstrate how the Webflux can also support the reactive programming, right? Or I mean the functional programming, right? So we are simply using functions. We're getting the user, we are mapping through the user, we are updating the data, and then we just flat map and then save the data and save the record, right? So once you've done this update user, the next thing that we probably need to do is maybe delete, right? To delete the data, right? So for our deleting, so if we delete the data mono, we're going to return a void, right? Now, right, we're going to return nothing. So in this case, I'm simply going to say delete user. So in this case, we need the user that we want to delete. So here I'm simply going to say return user repository dot delete by ID, right? So we just pass the ID like so. Then here switch if empty. If the user is not found, then we can simply throw an error, right, like what we did. So we can say mono.error if the user is not found, new exception. So this is not the best way of handling your exceptions, but this is just to demonstrate that it actually it's so we can throw your exception. So we can say user not found, right, something like that, right? All right, so like this. So once you have done this, so this is not readable. Let me just make this a little bit more readable. Yeah, like so. Okay. All right. So this is delete user, right? So this is going to be our service, which is going to represent our business logic, right? So once we are done with this, the next thing that we probably need to do is now to create our repository. So let's go ahead and go to the user controller, and then we create a class called user controller inside that package, right? So inside this user controller class, right, what do you want to do? This is the one that is going to communicate with the client, right? So we're going to annotate it with a REST controller, because this is going to be a REST controller. Then I'm simply going to have our default request mapping, right? So our request mapping, the entry point, I'm simply going to call it /API, like so. So for our controller, the first thing that we need to do, just like what we did to the service, we need to inject our service, right? Just like what we did in our service when we injected the repository. So we're simply going to use auto wired, then we simply inject our service, right? So this is just to demonstrate. So you could have directly so most of the things that we did in our service, we could have just directly do them here, so that we won't write much code. But this is just to demonstrate how you can, how you can join the two, like your service and your controller. But it's more or less like repetitive stuff. I didn't have to do it anyway. So, but anyway, so the first thing, so here we're just going to mimic like what we had before. So in this case, so I'm going to say find all users. I'm going to create a function for the first method. So I'm going to say public, right? So remember, for finding all users is going to return a flux, right? It's going to return a stream of data. So in this case, I'm going to say find all users. So find all users, like so. right? So I'm going to import Flux, right? So what am I going to do? I'm simply going to return user service dot get users, like so, right? So we are done. So before that, we need to put the endpoint, right? So for our endpoint, we need to use, so this is going to be a get request, right? So it's going to be a get request, and then we're going to get it to, let's say, /users. So it's going to be API /users. Then this is going to produce media type, right? So here we just want to demonstrate like the reactive part of it, right? Whether it will be reactive. So in this case, I'm just going to return an event stream, right? So for example, let's say there was some sort of, let's say, delay in getting our users. So we're just going to manually invoke a delay here later on when we demonstrate, so that we want to see if this is going to be returned as a stream, right? So remember, let's say we have 3,000 requests per second that is coming in. We want to sort of like stream the data as we get it, right? So we don't have to fully subscribe to the data to get naively get the response, but you can actually stream it as the data comes. So we're going to demonstrate it later. So I think for our user, our get users, I think it's now done. Then maybe the next thing that we need to do here, so maybe you can say response status. So for our response status, I'm going to say HTTP maybe accepted or something like that, or okay, right? Then the next thing that I probably need to do, so the next endpoint is going to be a get request again. So this one is going to be let's say get user, right? So I want to get the user by the ID. So we're simply going to pass the ID here, right? So inside, so this is going, so remember, it was, since we're getting a single object, right, it's going to be a mono. All right, so if it's going to be a mono, then we pass our model. So this one I'm going to call it find user by ID or something like so. Then inside this, right, I'm simply going to add a path variable to be able to access our ID, right? I'm going to put it in a path variable. Then here I'm simply going to say return user service dot get user by ID, yeah, like so, and then we pass the ID, right? And then we terminate. So this is how we're going to get the user, right? So like so, that's it. So the next endpoint that I want to create is the save, right? So for our save, I'm simply going to say public. So remember, save user, it was a void, it's not getting anything. Then so for our data, I'm going to use response body, right? So for our response body, I'm going to use my DTO, which is my model called users. So in this case, we simply say user service, right? Dot was it add user? Yeah, add user. Then we add the user, like so. Then for my mapping, my endpoint, this one I'm going to call it so this one is a post mapping, right, for my endpoint. So this is going to be a post request. Then I'm going to say API /save, right? Then in terms of what we're going to return to the client, we're going to say response status, then https dot, let's say, created. Do we have created? HTTP status dot, yeah, perfect, created, like so. So once we hit this endpoint, we just get the user, we just add the user. It's a post requests, right? Post mapping, these are all gets. So post mapping, and then we return, like so. That's it. Then the next one, or probably the last one, it's going to be update, right? Or update request. So this is going to be a put, right? So to update our data, we're going to say it's a put mapping. So for our put mapping, I'm going to say update. Then for my response status, I'm simply going to say http status dot okay. So it doesn't matter what how we are going to return the status. Then so for this one, so for our update, remember once our client hit this endpoint, we're supposed to return the updated user to the client. So it will be just a single instance, so we use mono. So we're going to say update user as our function name. So this is going to be called update user, like so. Then we simply get the data from the request body. So in this case, it's going to be of type users. So in this case, it's user, like so. Then we simply go ahead and return our user service dot, was it update? Yeah, update user. Then we'll pass the user, like so. All right. So once we have this set up, for the most part, I think we are actually done with our controller. So our controller, like I said, this is the endpoint to our API. Once the client hits any one of these, so this is update. Once the client hits any one of these endpoints, we're going to call the service, which will then call the database, right? So for the most part, this is how we create your RESTful API. I think the next thing that we're going to look at is we're simply going to run our application, try to run our application. Hopefully there are no bugs, and then we'll test it out. See you in the next one. So before we run our application, let's just simply go ahead and populate some data into our database, right? So what I'm simply going to do is I'm simply going to create a new file called data.sql, right? So inside this new file, I'm simply going to write some insert queries. So insert into users. So we're going to insert our name, surname, username, email, password. Then we're going to insert the values. So for the values, I'm going to say name, surname, username, email, so I'm going to say email user at gmail.com. Then the password, I'm simply going to say password 123, like so. So I'm simply going to copy this, paste it a couple of times. So here I'm going to say 2, 3, 4, 5, just to distinguish the data, right? So once we have this, the next thing that we probably need to do is to go back to our configuration file and then populate this data. So remember, this initializer is going to be run every time you start your application. So in this case, I'm simply going to say data.sql, right? So that it will reference our resource file, right? So these two files, the schema and the data.resource.sql, are going to be run when we boot our application. Then one last thing that you probably need to do is, since we're using Spring Webflux in our default applications, you probably need to enable the reactive CRUD repository. So let's simply go ahead and annotate it with enable R2DBC repositories, right? So what this does is it will make sure that our repositories are run, and also there's a relationship between the tables that we've created and that model, the user model that we created. So once that is done, let's simply go ahead and try to run our application. So to run our application, I'm simply going to say Marvin Spring Boot Spring All right. All right, so as you can see, our application has started on default port 8080, and it's using the NET server. So unlike the Spring MVC, which uses Tomcat, Spring Webflux uses the NET server, because the NET server is actually non-blocking. So let's simply go ahead and go to Postman and try to test our API. So once I'm in Postman, I'm simply going to try to get users into our port 8080, right? All right, so boom, it's working. So you can actually see that we've got these 3 users. So let's simply try get user by ID. So it was user, then we pass, let's say, ID. So okay, boom. So we've got the data user 2, right? Then we can try to what was the other endpoint? So if we go back to our application, right, so if we go back to our application, then we'll go to our controllers. So we can just try to run these endpoints. So let's just try update, right? So let's try to update the data. So let's go back to Postman and let's try to update. So it was API update. So for our update, it's going to be a post request, then inside the body I'm simply going to send a JSON file. So for updates, I want to update this user 2. So I'm going to update it with new records, right? So I'm simply going to say new record, then maybe surname. Then since it has options to either take the variables, I'm simply going to remove the rest. I just want to update the name and surname, for instance, right? So I'm simply going to name and surname like so. Then so it's a put request, actually, not a post. So if I try to say put, right, so remember it has updated our record. So it has updated the name and the surname, and then the username, the email, and the password were not touched. So if I try to say API users again, and I try to get the data, right, you can actually see that where is it? This user 2 has been updated with the new data. All right, so this is probably it. I think one thing that I just want to demonstrate, to lastly demonstrate in terms of testing our API, is I simply want to demonstrate like the non-blocking way on this API. So remember, for our events, for our get users, right, we produced so instead of producing a JSON, we produced a media type of type text stream event, right? So for us to be able to get these users, right, so what I'm simply going to do is in our service, right, so for example in this get user service, right, I simply want to actually go ahead and, let's say, for example, to put a delay here, right? So what I want to do here is I want to put a delay so that when I get the data, I want it to come as a stream, right, of data. So this is going to demonstrate the non-blocking way, or the asynchronicity of getting data from our net server, from our net server. So what I'm simply going to do, so this is where R2DBC comes into play, right? So we can see everything working together, the R2DBC, the non-blocking part, architecture of the Webflux. So here I'm going to simply say delay elements, right? So for our delay, I'm simply going to add a duration of seconds, right? So I want to delay, let's say, by 2 seconds, right, for example, right? So what we're expecting is when we hit the service get users, right, when it gets the data from the database, once it has found all the data, since we are subscribing to a flux, which is a stream of data from 0 to n elements, it's supposed to create that delay. So let me simply go ahead and restart our application. Right, so what this means is once the data is coming from our service, right? Since we have said it's a stream of data here in our controller, we're expecting the data to come as a stream, right? So our application is restarted. So let's just quickly go ahead and go back to Postman and then try to run that get user request. So I'm going to get all users, right? So I'm simply going to run it, right? So what we should expect, so as you can see, the data is going to delay 2 seconds and it should come as a stream. So for this one, I don't know why it didn't work. Okay, so this one didn't work. I'm not sure how Postman is. So let's simply try to do it on a browser, right? So let's simply go ahead and go to our browser and say localhost 8080/API/ let's say users, right? All right. So as you can see from the browser, the data is actually coming as a stream, right? So this will actually demonstrate the asynchronous part of the data, which means when you send our requests, the API is not blocking, right? So it means we don't necessarily have to wait for the whole result to be processed, and then we get the we naively get the response. So in this case, we'll get the data as a stream of data. So this was probably it. Thank you guys for watching. I know this has been somewhat a long video. So in the second part of our video, we are simply going to create a Spring Web Client where we're going to fetch data from this service. So stay tuned.